So hello and welcome to Scala.
You're about to attend the one of the last, if not the last, remaining independent Scala conference in the world. By independent, I mean a conference that is not organized or baked by any company, but rather made possible by a small bunch of dedicated people who volunteer their free time to make it happen. Namely, you have Jonathan, that you have met at the entrance, you have Mark, and you have Lucas, who is somewhere. And I guess they deserve a very warm round of applause. So I wouldn't think that the title of my talk today would align so much with the news from the other side of the pond. Sorry about that. But before we begin, I must warn you, normally the role of an opening keynote is to cheer everyone up and to get them pumped up for the rest of the conference. And today might not be the case, so my apologies in advance. So before diving into it, let me introduce myself briefly. I'm Valentin. I've been a software developer for the past 15 years. I started my career on a very small platform called the Nintendo DS, where I programmed, obviously, on C++. It was a very weird little machine with only 4 megabytes of memory split in different banks where you cannot do whatever you want. It was fun, but a little bit tricky, but fun. Then, because of the crisis in the gaming industry in France, I lost my job, and so I moved on to working in Java, developing web applications that ran on small on-premises racks of servers. And in 2012, I discovered Scala at a conference, and since then, almost, I've been programming Scala, and pretty much as everyone else, my code now runs somewhere in a big data center on the cloud. And during my 10 years of Scala experience, I've been giving talks around the world. I've been building or attempting to build some libraries and contributing to some libraries. I've been helping organizing meetups and conferences as this one. And so that's it, that's me. But back in the days when I was still on social media, I went by the nickname Override Lazy Val. It's by no chance that I picked these 3 keywords that appear in that order only in the Scala language, because I like this language very much, but also because I am an exceptionally lazy person. It doesn't mean I cannot work, but my brain cannot fathom complication. If someone talks to me about some complicated problem, after 1 or 2 minutes, my brain stops getting the details in, and really shuts down, and I'm and I just forget about everything that's told to me. And that's pretty much why I really like Scala. It's because it allows me to be lazy. With the right tools and the right discipline, the Scala language works more than me when I'm writing programs. You can have, in Scala, basically, if you use the type system correctly, if you use a few functional programming approaches, you don't really need to have all the details of your system in your head. And basically, when I come back to some piece of code a few months after I've been written them, I just had forgotten everything about the detail, but I just need to read the type signatures, the type structure, and I remember what I need to remember in order to be productive and to develop new features or fix bugs and so on and so forth. So, of course, getting to that point where I can take a nap while the robots are working for me, it takes a little bit of work beforehand to teach myself and the little robots how to take care of the garden. And that's a process that yields something that I call the distillation of Scala code. When I tackle a new problem, when I need to program a new feature or start a new project, I start with very naive and simple things that forget about the detail. I write a bunch of case classes or IDTs, a bunch of type signatures. I plug these functions together. Then I start implementing them. And then, because I fail implementing those, I realize that I need to change my signatures, adapt my ADTs, and so on and so forth. And so at any point, at any step in that process, I don't really think, because I am lazy. I just let the structure of the type and the functions work for me. And in the end, I end up with something that is rather simple and that works. So I distill the code. And even more, once you work on a specific project, sometimes you realize that you are doing the same thing over and over again. And so you have, with the Scala language, the possibility to build a small DSL for solving that problem more simply and more concisely. And you end up with a code base where 99% is very simple, very readable, and somewhere you have some boilerplate, some magical code that will do shenanigans with the type system or shapeless or derivation or whatever. So yeah, distillation. And as an example of that, back a few years ago, I was working at a company that had to handle a lot of documents for legal processes. And there was a bunch of rules that we needed to enforce about these documents in order to filter them, to route them to the right processor. And so we were repeating ourselves a lot. And so because I was tired of it and I was lazy, I decided to write a small DSL with nice combinators, symbolic combinators for just solving that problem. It was really simple, just a file with a few combinators. But one day, a guy from another team who was not working in Scala at all, in fact, he had no knowledge of Scala, came to me and told me, you know what, last weekend production went down and I had to fix stuff, and so I had to look into the files where you use that DSL. And it was so simple that despite me knowing nothing about Scala, I managed to make the change I needed very easily, and it worked on first try. And so I felt it very nice because he didn't stop at not understanding how things were working, because he understood what things were doing. Because you can simplify your code that much that the syntax doesn't get in the way. And even not knowing the syntax, you can make changes, and it works on production. So that's pretty much why I love Scala. And considering it such a superior language that has so many features, so many properties that help us kill whole categories of bugs and be so productive, I was pretty much convinced 5 or 10 years ago that Scala was due to take over the whole industry. That people who had to see the light at some point and adopt Scala, that was just necessary. And unfortunately, as more often than ever, I was wrong. You are attending the last remaining independent conference about Scala, but you are also attending the smallest edition we ever had in terms of number of attendees, in terms of numbers of submission to the CFP, in terms of number of sponsors. And it may be just my feeling, but there are not as many job offers around Scala that there were 5 years ago. My boss, who claims that his company is maintaining the biggest Scala code base in the world, also tells me that Scala is dying. So the situation doesn't feel as good as it was 5 years before. So I started wondering why that is. Maybe it's just my feeling because, as I said, I'm not that much on social media anymore, and I don't get much news apart from Scala news every week. But I have this feeling that the situation is not as good as it was before. So I started to think and ask myself, why is that? And I came up with a few explanations. First, of course, there was COVID. COVID made us stop having live conferences, live meetups. It also has more subtle effect. If you think about it, Scala has always been a niche language, meaning that for it to get adopted in companies, you have to have someone in that company that believes in Scala and pushes toward these adoptions. And the problem is that COVID also made a raise to remote work, generalized remote work. Meaning that even after COVID, when people started to come back to the companies, not everybody was there for the live meetings inside these companies. And if you are not there, it's difficult to push, to advocate about something. I even heard a story about a company that had a Scala code base, but one of the managers was not happy with Scala for probably personal reasons. And that manager took the opportunity of a meeting in the office while the Scala people were not there to decide that the code base would have to be rewritten in Java. And because nobody was there to oppose this decision, the decision was taken, and now they are suffering with Java again. So that's the effect of COVID that stopped the growth of at least the community events. There is another thing that also explains why there are not as many, because the pandemic is past us now. So we should have as many conferences and meetups as we had before, because nothing stops that. But it isn't the case. So that's the moment of the talk when I don't make friends. I think we should also address the elephant in the room. You see, we are a very small community. Don't lie to ourselves. But even though we are a small community, this community is widely divided. There have been lingering conflicts between people inside the community that tend to spread to the people who are not involved in those conflicts. And even though it doesn't show much from the outside of the community, or even for you who are not involved in making the community live, it has probably burnt out a lot of people who, like me, organize meetup and conferences, because people who are taking part in those conflicts, they tend to try to put you on the side of the conflict, even though you want to remain out of the conflict. In Scala.io, we've always thought ourselves as a neutral ground where people could come and discuss, even if they disagree, and even if they strongly disagree, because disagreement is normal. But it turns out that because at some point we invited someone on the one side of the conflict, people from the other side of the conflict think that we are bad. And it goes both ways. So now, either side of the conflict, even though we start to remain neutral, tend to see us as the enemy. And I mean, this is a little bit childish. And if you want to disagree with someone, if you want to dislike someone, be my guest. But please stop trying to bring everyone in your own battles. It's probably not productive, and it, I believe, hurts the community a lot. So that's the end of the parenthesis, and I will start trying to make friends again. But this situation, and also the fact that I was facing depression at the time, made me stop using social media and basically crawl into a cave from which I didn't went out that often. So that's also probably the reason why the things I will tell after that might sound outdated or even wrong. That's because I don't get all the information, so please pardon me. But nonetheless, I stick to it. So that was the reasons internal to the community why things are shrinking. But there are also reasons why the community was not as big as it could have been. And I think this has to do with our obsession on functional purity, which I exemplify here with all the monad tutorials that we had. I mean, talking about monads in great detail is really, really nice and interesting once you understand why monads are important. But from the outside of the community, for someone who has not been starting their functional programming journey yet, talking about monads, and especially saying phrases like, a monad is just a monoid in the category of an functor, what's the problem? It's funny because it's a private joke, but if you're not in the group who understand that joke, it just push you back. And by the way, even if it's a good joke, that sentence doesn't bring any insight to me unless you say it's a monoid in the category of functors, but it's not the only one. That's interesting, because then you talk about applicatives, and that's cool. But otherwise, you are just flexing with big words, and that doesn't move anything forward. So even though I strongly believe in pure functional programming, I think insisting on pure functional programming too much pushes people away. And Scala is an hybrid language. You are not forced to do functional programming with it. It's good if you do, and you should. But if you want to bring people in, I think it's not the thing you should insist on in the first place. You can still insist on that, but after they came in, and help them on their journey on functional programming. But honestly, the most reason why the community is not as big as it could be and is not growing as fast as it was is also because of external reasons. First, so that's a kind of reasons that I call fewer or lesser incentives. Things that diminishes the incentives of moving from Java to Scala, for example, is the fact that Java is stealing features from Scala for the past 10 years. If you look at the new language features in Java, they are pretty much all inspired from Scala, which is good. It's a sign of success. It means that Scala was right, and Java is realizing it. They now have lambdas, they have pattern matching, they have case classes, they call it record, but et cetera, you name it. So that's good. It's a sign that we are on the right way, but it also lowers the incentive of moving from Java to Scala, because now you also have these features in Java. Even though we know as Scala developers that the Java mimic of the Scala features is not as good as the real deal, but still it lowers the incentive of moving from Java to Scala. Another thing that lowers the incentives of moving to Scala is the way Spark deals with Scala. You see, Spark has probably been the biggest reason why people adopted Scala in the past 10 years. Just by a show of hands, who has started Scala because of Spark? Oh, I would have thought more people than that, but anyway, I'm always wrong. And the thing is, Spark is not really a Scala thing. It's a thing that happens to use Scala. But they are still stuck in Scala 2, and they will probably never get into Scala 3. They now make it possible to use Spark without writing a single line of Scala. And so that incentive went away. And also something very obvious, but the thing is, Scala allows small people to achieve a lot and produce robust software. That is not a good business plan for consulting companies. What you want as a consulting company is to sell as many developers for as long as possible to clients, rather than selling small teams of developers for short times to many, many clients. It's easier if you use Java, because you will need 10 Java developers for 2 years for a thing that 3 Scala developers could have done in 6 months. So we have fewer incentives as before. We have structurally fewer incentives as Java for the biggest people who hire, biggest group of people who hire developers, which are consultancies. And so we are a little bit doomed. And before preparing this talk, I have very little time for preparing it. So I ran a survey on 5 former friends and former coworkers. So that's not at all representative. They are all, so we met back in the day when I was doing Java, and now they are still doing some Java for some, or doing Ruby for others, but none of them has ever adopted Scala. And so I asked them, why have you never tried Scala? So some told me, well, I tried, but at some point I ran into a problem. I asked a question on some forum, and my question was met with snarky or slightly pedantic answers that made me feel a little bit dumb. I think that's something from the past. I think that we have amended ourselves from that, but it's true that back in 2010, it was easy to be looked down on chat or forums when you asked beginner questions. I think we did a pretty decent job in changing that. The second thing that came up was that there seems to be so many ways of doing the same thing in Scala. It doesn't feel very mature, and so adopting it feels a little bit risky. And that's an argument that I can understand, but then I answer, isn't it the same in JavaScript? If you remember that joke saying that every day there is a new JavaScript framework, I don't know if it's still the case because I live in a cave, but apparently what's a problem for Scala is not a problem when it comes to JavaScript. Puzzling. Another and very worse argument, because it justifies itself, is from so 2 sides of this argument. One is from a friend who became a manager who told me that, sure, I could adopt Scala and have find 1 or 2 senior Scala developers for building a system. It would be robust and good, but then they will leave, and I have no idea how I could hire more people because there seems to be such a small market. And another one who is still a developer told me, I never invested too much time on Scala because there are not so many job offers. So you see how this justifies itself. There are not so many job offers, so I won't learn Scala, so there are not so many developers, so there are not so many job offers, and so on and so forth. But isn't that the same with Rust? I mean, where are the 5 or 10 years experienced Rust developer out there? They are nowhere to be found. So it means that companies are willing to train people to become Rust developers, but they are not willing to do the same for Scala developers. And in fact, the friend who is a developer who told me I never invested on Scala because there are not so many job offers works for a company that runs trains. And they have 2 departments for software. One for web application and data, where they use mostly Java, and Scala is almost forbidden by law, by internal law. And they have another department who write C and C++ for actually running the trains. And this department, they are making or producing new Rust developers because they are all in on Rust for replacing C and C++ in their systems. So that got me puzzled. How come some seemingly rational arguments are applied to Scala, but not to other languages? And again, I think it's a matter of incentives. If you want to have some code run in the browser, you have no choice but to write something, at least something that will produce some JavaScript. You could use Scala.js, but that's another question. So JavaScript is there, and you have no choice. So the incentive is much bigger than, yeah, it doesn't seem very mature. There are so many ways to do the same thing. That's not a problem because you have no choice but to use JavaScript. And for Rust versus Scala, they both share the same properties of enabling developers to make all classes of bugs not representable. So that should be the same for both. But think about what kind of systems are built currently with Java and what kind of systems are built with C or C++. With Java, we basically ultimately produce web pages or dashboards about data. If something goes wrong, somebody might lose a lot of money, but nobody gets hurt. Whereas systems that are built in C and C++ are mostly embedded systems or systems for driving train automatically. And if something goes wrong, people get hurt for real. So the incentive of suppressing all classes of bugs is bigger when these bugs can hurt people rather than when these bugs can, at worst, make somebody lose some money. So I think that's the reason why so many companies are keen to make Rust developers out of, not nothing, but out of C developers. And at the same time, so few companies are keen to make Scala developers out of Java or Python or you name it, developers. So as I said, I didn't cheer you up. I see your faces, and I think I did a pretty good job in that extent. But of course, I won't leave you without a few specks of hope. So first up, in order to welcome newcomers, because we will find a way to have people come to Scala again. And a recent experience of mine raised that idea. So as I said, I had in the past few years a few episodes of depression. And when you live in a cave and work 100% remote and you are depressed, your productivity is not that good. And in both cases, I was literally saved by doing some pair programming sessions with coworkers. And more specifically with coworkers who were not very familiar with Scala. And so we sat down for 1 or 2 hours on a video conference, and I explained them how we did this and that in the project. And after those, I was motivated again. I was happy, and they were happy, and everybody was happy, we're happy, and it was awesome. So I was thinking, what if, and probably some of you for their projects or libraries are already doing that, but what if experienced Scala developers could volunteer small amounts of their free time, like 15 or 30 minutes a week, for example, in order to do pair programming sessions with newcomers who have problems. Because you see, when you're a beginner in something, asking a silly question, a question that you think is silly, in a public chat, it can be intimidating. And answering these kind of questions that you might have already answered dozens of times, it's easy to do answers that are a bit dry or do not make the people who ask them feel very welcome. Whereas if you sit together for 15 or 30 minutes, talking about the problem and meeting each other for real, first you may have a chance to make new friends. And I think it will be a much better and much more productive experience for both the side of the question. Not only for the people asking, but also for the people answering. Because sometimes when answering a question and seeing that the person that get the answer didn't completely understand what you said, you ask yourself, did I answer correctly? Did I explain myself correctly? So everybody will progress if we do that. So if you're interested in helping me making that happen, let's talk after the presentation. Maybe we can come up with something very simple, but that would make that possible. Second idea, and I think that's something everybody can start doing in their own companies, has to go with not agnosis, but persuasion. I think we are, or every one of us, are the best advocates for Scala and for functional programming. We just need to do it right. I am currently working with Databricks. We are building a transpiler that is supposed to be able to take SQL queries in pretty much any dialect and translate those in the equivalent query in Databricks SQL, but also help to migrate workflows and notebooks and these kind of things. When I interviewed with the guy who will become my boss, I talked at length about a previous experience where I did similar things, translating SPARQL query language for RDF into Spark, using purely functional programming, recursion schemes, and all the good stuff. And at the end of the interview, he gave me some feedback, and he's a very no-nonsense person. Very smart, but no-nonsense. He detects bullshit at 1 kilometer. And he told me, I don't give a crap about your functional programming thing, but you seem to know what's the kind of problem when transpiling from one language to another. You seem to have at least common knowledge about the Spark internals, so I will hire you. And so it's the guy who claims that Databricks, and I believe him, is maintaining the biggest Scala code base in the world. And as such, they have very strict guidelines about how you should use Scala. The rule of thumb he gave me was if someone needs to wake up at 4 a.m. because production is on fire, they shouldn't need more than 2 minutes in order to understand any file in the code base. I think it's a good rule. But as a result, there are many things we are not allowed to do with the Scala language. The biggest is we are not allowed to write the word implicit. So that makes for a very dumbed down Scala. And of course, cats is out the window. Recursion schemes are out the window, obviously. And so I was a little bit baffled and frustrated at first. I thought to myself, well, that won't be fun. I will suffer a lot. And in fact, turns out I didn't. It's pretty smooth. It's refreshing to do Scala as just a better Java. But of course, so we are building a massively recursive program that parses incoming queries, traversing that tree to translate it to some intermediate representation, then traverse it again to make some optimization, and traverse it once again for outputting a string that contains the output query that we have translated. So a lot of recursion. And of course, because we were initially using Scala just as a better Java, we were relying on exceptions for control flow, because why not? And of course, because SQL dialects tend to be a little bit complicated, it was obvious that we wouldn't get it right on the first try, but rather incrementally improve our parser and generators and so on, thanks to a whole lot of test queries. So basically, we have unit tests, or coverage tests, or acceptance tests that fail a lot, and we try to make they fail less. But the problem is when you rely on exceptions for doing that, your program stops at the first exception. And so for the same query that may have multiple problems in it, you will have to run the test multiple times until you get all the errors. So when that problem became really prominent and was preventing us from making quick progress, I suggested we used some kind of, is it readable? It's not readable. Some kind of, I never said the word monad, but some kind of monad. So if you have good eyes and can read this, it's called result, and it's some kind of hybrid between either and validated. So it's a monad and an applicative, if you want. You have three cases: OK for the happy path, KO for errors that are not recoverable, and partial that will still try to build something, but also accumulate the errors you have encountered thus far. And of course, once you get a partial, you can never get a OK again. You will remain in partial unless you have a KO, where you will be a KO and everything will stop. And because that was solving an actual problem we had at that moment in the code base, my boss accepted that I refactored everything to use this result instead of throwing exceptions when something went wrong. A while after that, not that long after that, by the way, oh yeah, and error is our own type of error that I made a monoid so that it works. But of course, never write the word monoid, never write the word monad, never write anything like that, no implicits. It's just functional programming in disguise. And a while after that, we realized that for migrating workflows and notebooks and so on, we would need to also output some Python. And the problem with Python is that it's a indentation-sensitive language, meaning that you need some way to keep track of what level of indentation you are. And so my boss got a first stab at it. He put a context object in every function with a variable in it, a mutable variable in it, and he incremented and decremented the indentation level. And of course, he ran into problem because sometimes he forgot and the output was all broken, and it was difficult to track where the error occurred. So that's when I came up with this new monad, without saying that this is a state monad, but it is a specialized state monad with a state called phase, which is something where we say where we're at in the tree, where we're at in the process, and also we have an object for indentation and formatting. And it wraps around results so that it can also accumulate the errors, and that's it. Very little bunch of lines of codes. Again, no magic. The signatures are acceptably not too complex. So, and because, again, it was the right moment and it solved a problem we had, currently, I was allowed to do that. And finally, that's where I, again, stopped making friends because that is dirty. Finally, we needed, because we are in a vastly recursive program with explicit recursion, and we also have a whole part of the team who is coming from Python and not very familiar with Scala and functional programming, so knowing where to put the flat maps and so on is not an option for them, at least for now. So I decided to wrap everything in a string interpolator that basically acts as my applicative combinator. And that's the two instances. So I have this extension method sequence for sequencing a bunch of my, a list of my state monad. And this interpolator, these are the two instances of the word implicit in the whole code base. Its implicit class is almost okay with the guidelines. And in the end, it allows you to do these kind of things. You have the code interpolator. Expression is basically the recursive call for the rest of the generator. And you just pipe things together. And if any error occurs, for example, in array access here, if an error occurs in the first or the second or both expressions, you will get both error at the end. And you will still get something output, but with comments around the errors. And everybody is happy. The code is fairly readable and almost easy to write. And we are happy, and people are starting doing functional programming without even noticing it. And that's my point. I had to put some code on some slides, but that's not really the point. The point is that if you want to convince people about something they are not convinced about, you cannot go up front, as I did during the interview, bragging about functional programming and recursion schemes and so on, because they won't care about it. They won't be convinced. You have to wait for the people to suffer, and then you propose them a solution for their suffering, and then you convince them. So I think it's our duty, everyone in this room, to be aware of when people are suffering, and then boom, you propose a solution. Later in this conference, you will have talks about full stack Scala, for example. And demonstrations on how you could scaffold a full stack Scala application in a matter of minutes. So watch this talk carefully, and when your boss needs to find a way to spawn a new small web application in a hurry, you will have something to say, hey, I can do full stack Scala. Look, it's a command line, and bam, you have a Docker that runs and everything works. So it is our duty to remain aware of moments where we could push our pawns or play our cards in a very effective way and non-violent way. Like, it's not, Scala is better. I have the truth, and just believe me. People won't believe you. But if you wait for the right moment, you will certainly have a good point. And finally, I think, but this is only vapor, but I keep thinking about what could make Scala unique to the eyes of the outside world. And one feature that we have that no any longer language has is tasty. And tasty is awesome, and I believe we are not using it to its full power yet. And so my hunch is that the next killer thing coming from the Scala community will make a creative use of tasty. I have an example from Jonathan. We're starting to use tasty as a serialization format, for example. It's fairly simple. You compile a small file that just creates objects. Then you get the tasty file for it. You ship that tasty file. And on the receiving end, you load that in a class loader, and bam, you have data. And it works even if you have different versions of Scala on both ends and so on. So we could imagine something very crazy that tasty makes possible, and that would be impossible or impractical in any other technology. And if we get that, it will bring the incentive back because we will have something that the others cannot have and cannot steal from us. So again, it's your duty. I lack imagination, but probably someone in the room will have the imagination for finding smart ways of using that features of ours that nobody else has. And so lastly, and more importantly, I think our duty is to share our enthusiasm, our love for this language, talk more about our success stories. Even though we don't think it's that much of a success, I think we need more success stories. Like even a small post on Twitter or whatever saying, oh, today I did that and that made me feel happy. And share the love of Scala. And that's, I think, the only way to get this community become vibrant again. So yeah, that's it for me. Thank you.